Hi there. In this video, we'll take a continued look at Congruence Standard 2 from the Common Core Standards. And again, we're focusing on the aspect of the standard where we learn to describe transformations as functions that take points in the plane as inputs and give other points as outputs. Let's try to understand what happens when we apply the function rule that takes a point x comma y and transforms it to the point negative x comma y. To understand what this rule does, let's choose a point for our input, about 5 comma 2, and we'll call that point A. So our input is the point 5 comma 2. This function rule says take the number x and transform it to the number negative x. So in this case, we start with 5 and we end up with negative 5. We're then supposed to take y and leave it alone. That's easy. Take 2 and leave it alone. We'll call the output A prime. So the output has coordinates negative 5 comma 2. So let's go to negative 5 comma 2. Okay, so we started here and we ended up here. In an effort to try to understand this transformation, let's just make a little drawing here, connecting point A to point, A prime. And it really does help for purposes of understanding the effect of a transformation if you actually choose several inputs and produce several outputs. Eventually, when you do that, you'll become convinced that this transformation just reflects points across the y-axis. Here's the summary. This transformation carries each point in the plane across the y-axis, so it's a reflection. One further example to look at in this video, let's look at the function rule x that takes x comma y and produces y comma x. We'll choose an input, about 8 comma 3. And we'll call that point B. The coordinates of point B are 8 comma 3. Let's apply the function rule. This one's a little bit different from some of the others we've looked at so far. It says take your first number and move it to the second position. So the number 8 starts out in the first position and ends up in the second position. Then take whatever number is in the second position and move it to the first position. 3 is in the second position, but it moves to the first position. Okay, so we started at 8, 3, and we end up at 3, comma 8, which is here. Again, it really helps if you do this process several times with several points, choosing many inputs and producing many outputs. Eventually, when you do that, you'll see that every one of those input-output pairs lie on opposite sides of this line, unless you choose a point right on the line. So in particular, each point is reflected across this diagonal line. Notice the coordinates of these points on the line have the same x and y value, 1, 1, 2, 2, etc. In general, the x and y coordinates are the same along any point on the green line, so its equation is y equals x. Here's a summary. This transformation carries each point in the plane across the diagonal line y equals x. Another example of a reflection. Hope this video helps you to master Standard 2. Thanks for watching.